After the design and tree assessment phases are completed, measures must be taken to protect trees selected for preservation. Because the arborist's ability to treat trees damaged by construction is limited, it is vital that the trees be protected. When possible, measures should be taken to increase tree vitality prior to construction. Depending on site conditions, this may include, among others, water management, mulching, fertilization, pest management, and/or application of tree growth regulators. A healthy, vital tree will be better able to recover from minor to moderate stresses that result from construction. The single most important action that can be taken at the start of the construction process is to set up construction fences around each tree or group of trees that is to remain. This area is called the Tree Protection Zone, TPZ. The TPZ is the area around the tree or groups of trees in which no grading, excavation, or construction activity is to occur. Fences should be placed as far out from the tree trunk as possible. As a general guideline, the TPZ should be 1 foot, 0.3 meters, diameter for each inch, 2.5 centimeters of trunk diameter for young trees or species that are tolerant of construction. This distance should be increased for older trees and species with moderate to poor construction tolerance. The size and shape of the TPZ also depends on root and crown dimensions and development constraints. The picture shows a very poor example of a TPZ. The TPZ should be as large as possible, protected with stronger, sturdier fencing. The intent is not merely to protect the above-ground portions of the trees, but also their root systems. Remember that root systems can extend much farther out than the drip line. Arborists should work with construction personnel to keep the protected area clear of building materials, waste, and excess soil. No digging, trenching, compaction, or other soil disturbance should be allowed in the fenced area. Within the fenced area, competitive weeds should be removed and mulch should be added to the entire area. If at all possible, it is best to allow only one access route on and off the property. All contractors should be instructed as to where they are permitted to drive and park their vehicles. Sometimes this same access drive can later serve as the route for utility wires, water lines, the driveway, or other paved surfaces. Limit storage areas for equipment, soil, and construction materials. Specify areas for burning, if permitted, cement washout pits, and construction work zones. These areas should be away from protected trees. Mulch can be used to protect the soil surface and reduce the potential for soil compaction on construction sites. Spreading a 6 to 12 inch, 15 to 30 centimeters layer of coarse mulch, such as wood chips, on the soil surface around the tree helps to disperse the weight of construction equipment. Additional weight dispersal can be obtained by placing large plywood sheets over the mulch or by the use of proprietary trackway and protection systems. Construction mulching is a temporary measure, and the mulch cannot be left in place at a 6 to 12 inch, 15 to 30 centimeter thickness for a prolonged period of time. If the mulch has not reduced to an acceptable thickness on its own, it must be removed carefully so as not to damage the trees in the process. An alternative is to spread the mulch, dispersing it to a layer of 2 to 4 inches, 5 to 10 centimeters, in depth. Mulch should be added to the tree protection zone as well. It is important to work together as a team. The best laid plans between arborist and builder can be destroyed by one uninformed subcontractor. The consulting arborist should visit the site as frequently as possible, at least once a week. Vigilance will pay off as workers learn to take the arborist's recommendations seriously. It is a good idea to take photos at every stage of construction. If any infraction of the specifications does occur, it may be important to link cause and effect. It is not unusual to go to great lengths to preserve trees during construction, only to have them injured during landscape installation. Installing irrigation systems and rototilling planting beds are two ways that tree root systems can be damaged. Careful planning and communicating with landscape designers and contractors is just as important as avoiding tree damage during construction. Trees on a construction site may require several years to adjust to the injury and environmental changes that occur during construction. Stressed trees are more prone to health problems such as disease and insect infestations. Arborists should plan for continued maintenance and monitoring of the tree's health, structure, and overall vitality. Despite the best intentions and most stringent tree protection measures, some trees may still be injured by the construction process. There are a few remedial treatments that an arborist can use to help reduce stress and improve growing conditions around the trees. Unfortunately, the ability to restore trees damaged by construction is very limited, and this is why the emphasis should be placed on protection. Grade changes can be devastating to trees, even if the change is not severe. If the grade must be lowered, the ability of a tree to survive depends on several factors. The most important is the amount of root system that will remain after grading. Other important considerations are the tree species' tolerance to root loss, the degree to which the grade is lowered, the soil conditions, and whether irrigation will be applied. If the grade must be lowered completely around a tree island can be constructed. Obviously, the greater the percentage of root system that remains at the original grade, the greater the chance of tree survival. If retaining walls are constructed as part of the grade change, drainage must be considered. Sand is sometimes used as a backfill behind the walls to promote water movement to the drain. Increases in grade may require major steps to protect the tree. Sometimes aeration systems are installed to preserve trees, and designs of complex aeration systems and tree wells are described in various texts. There is little research, however, to confirm the value of these systems. Very large tree wells may keep soil fill far from tree trunks and minimize the percentage of the root system covered. Small diameter wells built around the trunks of trees are rarely adequate to protect the tree. Some specifications call for use of gravel or stone below the fill soil to increase water and oxygen penetration. However, the opposite occurs. If soil is placed over gravel, water will not drain out of the soil layer until the saturation point is reached. It is better to place the fill soil in direct contact with the original grade. Fills that will support structures or pavement are engineered to create a stable building base. As described in a previous section, building bases are built by removing the topsoil, including roots, and adding layers of compacted soil. Thus, where engineered fills occur near trees, roots are removed and a condition is created in which new roots are unlikely to develop. Tree stability should also be considered. The removal of structural roots may create an unsafe situation. If no structures or pavement will be placed on the fill, be sure to minimize root damage during the installation. Heavy equipment used to install a fill soil can injure roots near the soil surface and cause soil compaction. Using small equipment and hand tools can reduce the potential for damage. After fill is installed, it is important to ensure that the original root zone remains hydrated. Similar to the problems created by soil compaction, placing soil over the root zone of trees can adversely affect root growth and soil biology. Soil moisture status in the root zone should be monitored, such as through the use of a tensiometer, and irrigation may be needed. The most effective treatment, however, is protection, or keeping any disturbance outside of the tree protection zone. Because construction can affect the structure and stability of a tree and new targets are often created, it is important to perform a risk assessment. This assessment should start with a visual inspection of the tree and surrounding area. Additional inspections may be warranted when the arborist needs more information to assess specific tree parts or the risk to high-value targets. An often overlooked method of reducing hazards is to move objects that could be hit or to limit access to the area into which the tree could fail. Branches that are split, broken, diseased, or dead should be removed. Additionally, pruning may be necessary to raise the crown and provide clearance below. Old recommendations suggest that tree canopies should be thinned or reduced to compensate for root loss. There is no conclusive research to support this practice. Thinning the crown can reduce the tree's food-making capability and may stress the tree further. It is better to limit pruning in the first few years to risk reduction, especially in large, mature trees. If branches or tree trunks need additional support, evaluate the benefits of installation of cables or bracing rods. If cables or braces are installed, however, they must be inspected regularly. The amount of added security offered by the installation of support hardware is limited, and not all weak limbs are candidates for these measures. Sometimes the bark may be damaged along the trunk or major limbs. If this happens, the loose bark should be carefully removed, leaving the attached bark intact. Jagged edges can be cut away with a sharp knife, taking care not to cut into living tissues. This procedure is called bark tracing. A common practice used to be to cut the perimeter of the wound into a smooth shape. This has been shown to be of little or no value and can make matters worse. Wound dressings were once thought to accelerate wound closure and reduce decay. Research has not substantiated this, however. Some studies have shown beneficial effects in specific cases in reducing borer attack, oak wilt infection, or control of sprout production or mistletoe. However, wound dressings are primarily used for cosmetic purposes and are neither required nor recommended in most cases. If a dressing must be applied, only a light coating of a non-phytotoxic material should be used.
All pruning cuts over 1 inch in diameter should be treated with a tree wound dressing to prevent the entrance of wood-decaying fungi.
One of the most important treatments following construction damage is to maintain an adequate but not excessive supply of water to the root zone. If soil drainage is satisfactory, be sure to keep the trees well watered, especially during the dry summer months. A long, slow soak over the entire root zone is the preferred method of watering. Frequent, shallow watering should be avoided, and water should not be directed at or near the trunks of trees. If drainage is poor, the limitations need to be identified and corrected.